Hello all, myself Prarthana JV, Assistant Professor ISC SWOT. In this particular video, let us understand about bioremediation and biomining using microbial surface adsorption procedure. So basically these are the procedures that are used to remove impurities like lead, cadmium, mercury, arsenic being heavy metals which are very dangerous to the environment, and also at the same time it is humanly impossible to remove it manually. So we are going for this procedure. So first let us understand what do we mean by bioremediation and biomining. So these are the two related, but yes, they are used for different purposes of using the living organisms or microorganisms to clean up the contaminations. Bioremediation in the first place uses microorganisms, plants and animals to clean up the contaminated environment like water, soil and air. So here it is a natural process. It cannot be, it can be accelerated. It is controlled basically. So the goal of bioremediation is removal of the contaminants from the environment to give an healthy state to that particular contaminated environment. So biomining is a similar process, but it is contrary to it. It is using microorganisms to extract or to obtain the valuable minerals from the mines, or ore deposits. So this process involves use of microorganisms to dissolve mineral from ore, creating a solution that can be separated and purified to obtain the valuable minerals. Biomining is often used in the extraction of metals such as gold, copper, nickel and many other using a traditional process. It is basically a disadvantage. Using this, it is more cost effective. So bioremediation and biomining uses microbial surface absorption. In the process utilizes microorganisms to remove the heavy metals. So the steps includes identification of metal or any contaminant, what kind of a contaminant is present and where it is basically present. Then isolation and characterization of the contaminant. So we have to decide what kind of a microorganism can be used, which strain is useful in this. Then culturing and enrichment of the strain. So we have to grow that particular strain in the given environment. Preparation of microbial suspension. So you are going to prepare a solution or a suspension where we can basically deploy. Application of microbial suspension to a target. Then the process or sequestration basically of metal basically happens. Then the contaminants are said to be removed. So example, for lead removal we use a strain called as Pseudomonas or Bacillus sp. For cadmium we basically use Capria viridis, Trichoderma sap. For mercury we basically use Pseudomonas puteri. Similarly for arsenic, Chavanellas. So these are the method used, these are the strains used for the removal of metal. These are some examples. So how do we basically separate these metals? First one, phytoremediation using microorganisms, then chemical extraction, biosorption, physical removal, then electrochemical method. So out of all the procedure that is available to us, we can straight away say that the advantages of bioremediation and biomining, since we are using microorganisms or organisms for the removal of waste and the metal extraction, the process is environmental friendly, it is cost effective, it is selective. You can, since you are selecting a target of strain, it is selective process, it is more effective, controlled and a sustainable process. The limitation of this particular bioremediation and mining is it is slow. Since we have to prepare a suspension then apply, it is a slower process. We cannot assure that it has been completely removed, so incomplete removal is the case. Then even after removal of contaminant there can be a microbial strains still in the environment. it is difficult to harvest, and also it has a very limited as of now it has a very limited application. Hope these concepts you people have understood. Thank you so much.